Hello everyone, this is Ashifa Anjum and in today's session we are going to see about variables and data types in Python. What is a variable? A variable is considered as a tag that is tied to some value in Python. Whereas in other programming languages like C and Java, a variable is an identifier or a name connected to a memory location. If we assign a variable a equals to 10, the address of the variable, that is a, the address, if we assign a variable as a equals to 10, it has a name and it has the memory location address. This is the address and this is the variable name, and this 10 is stored in this address location. In other languages C and Java, the address is for the variable. For variable a, 1 2 3 4 6 is the address, but whereas in Python the address is given to the value, that is 10, not for the variable. That is why the variable is considered as a tag that is tied to some value in Python. Every object, every value is considered as an object in Python. If a equals to 10, then the variable a, the name a is tagged to this memory location, sorry, to this value 10. The value 10 is stored at 1 2 3 4 6 location, and a is tagged to this value. If you assign 10 to value b, a separate memory location is not allocated, but this b is tagged to a. Now for the value 10, there are two variables tagged, that is a and b. Let's see another example. If a equals to 10, then a is tagged to this value 10, which is in the address 11221. If you assign 20 value to a, then this a is not tagged to this value 10, and now this a is tagged to this value 20, which is in the location 11222. That is, if you are changing the value of the variable, then the variable is tagged to that value, not to the previous value. Now the value of a is 20, value 10 becomes unreferred object. Now for this 10 there are no objects, that is there are no variables tied to it or pointing it or tagged to it. And now this value 10 is referred as, then this value 10 is unreferred object. So the garbage collected identifies this unreferred object and removes from the memory. So by this the memory will be saved in the, but when we use Python language, that is proper utilization of memory is done here. Okay, let's see the same thing in the IDE, that is I am using here IDLE interpreter, sorry, that is IDE. I will take the same example, a equals to 10. If we want to check the address of the variable, we are using ID function, ID of a, that is this is the address of a variable. If you give b equals to 10 and check what's the address of b, see these two addresses are same, 27611023842896. For both a and b variables, the address is same, that is both variables a and b are referring to the same value 10 that are in this location. If you give, if you assign, if you assign a equals to 20 and check what is the address of a. Now the address of a is different, that is 2761023843216. Now the variable e is not referring to the object 10 anymore. Now it is the variable e is object referring to value 20. So the address of this is this. If we print a, the value will be 20, not 10, because it is no longer uh, tagging to the value 10, but now it is pointing to the value 20. And if you give a value y equals to 20 and print y, and if we check the address of y, now the address of y and address of a are same, 27610 at the last 1616. The two variables a and y have same value. If we change the value y equals to 10, now it refers to the object. Now it refers to the value 10, and the ID of y is the ID of this 27160, and this is also 2716096 at last. If you print y, now the value is 10. As soon as we refer this object y to a value, change the object y to the some other value, it gets changed. Now the if we give if we assign a equals to 60 and y equals to some 40 and b equals to some 90. Now there is no value there is no object that is referring to the value 20 and 10. Later this 10 and then later the value 10 that is stored in the memory is is a, is a by the garbage collector is referred as an unreferred object. Sorry, the garbage collector identifies it as an unreferred object and it removes it after some time. This is all about the variables, how they are assigned. Now we will continue with our presentation. And the next is identifier. What is an identifier? A name in Python program is called an identifier. It can be class name or function name or module name or a variable name. If you are giving here a equals to 10, then this is a variable. A is a variable. Yeah, this is now if we, this is really confusing for us. Here a equals to 10 is we are assigning value 10 to a variable a. So that is a is referring to value 10. This a is also called as an identifier because the name of the variable is a. Here total equals to 123. The variable name, this is the variable, the name of the variable is total. So Total is also is an identifier. There are some rules while giving the name of an identifier or name to a variable. That the first rule is every variable should start with alphabets or underscore. The digits are not allowed while at the beginning of the variable. No spaces are allowed in the variable declaration except underscore. No other special symbol are allowed in the middle of the variable declaration. When you are assigning a name, in between we can use only underscore symbol, not other symbols like ampersand, dollar, hashtag, at. We should not use this special symbols. We can only use underscore symbol for variable declaration. A variable is returned with a combination of letters, numbers, and special character underscore. We can use digits, we can use letters, it can be a combination with the special character underscore. We cannot use any other underscore, and we cannot use a variable name that is a reserved keyword. If in Python there are few reserved keywords, not few, about 33 reserved keywords. These keywords we should not use them as an identifier name, as an identifier or a variable name. We'll check this thing in then ideally. And also the identifiers are case sensitive in Python. You have a given a equals to 10. If you print a, it will give. If you type a, just it will give the value. If I give capital A, it will show me the error as name error. Name A is not defined. If I assign some value to capital A equals to 89, and if I print capital A, then it will give me the correct answer. If I give name equals to D, some dog or something, name dog. If I use capital N A M E, it will again show me that name error. Also, we have already discussed that a variable name can be a combination of alphabets and digits. Now I'm giving the variable name as name12. Name12 equals to some John, and again I'm printing it. Give me John. I add dollar city equals to Goa. Show me syntax error, invalid syntax. It is showing invalid syntax because here I have used dollar symbol, which is not correct in Python while giving the name, variable name. It is the rule that we should not use any other feature, any other special symbol rather than underscore. So it is syntax error, invalid syntax. If I score city equals to Goa, then it's not showing any error to me. Underscore city, it will print Goa. And let us give a space in between city and state equals to JJK something. It is again showing invalid syntax because we have given space in between city and state in the variable name, which is again not satisfied with the naming rules of Python. So it is giving syntax error. When we want to show the difference by without giving space, we can use underscore in between. I'm giving same value to it. Now it is not showing me any syntax error. If I print this, we'll get the output correctly. These are the rules to be followed while giving the variable name. And also the variable name can be you can have a long length of variable name. Like I will just give some example. I'm giving this. If I print this PHVCBTSK BVJDB VJKB, it will print the correct output. But in where we can give a long length of variable name, but it is recommended to use short names. If we give long names also, it will accept that, but it is better to give short name. These are the naming rules, and this is the note. If identifier starts with underscore symbol, then it indicates that is private. Before the identifier or before at the beginning of identifier, if we give a single underscore, just one underscore symbol, then it indicates that is private. If we start with two underscore symbol at the beginning, then that is strongly private identifier. If identifier starts and end with two underscore symbols, then the identifier is language defined special name, which is also known as magic methods. For example, underscore underscore add underscore underscore. It means that add is special identifier that is special name defined by the language. This is also called as magic method. Now we will see what are the reserved words. In Python, some words are reserved words to represent some meaning or functionality. These are the words which are already inbuilt in Python language. While they are developing it, they have created or preserved reserved few words. Those words are called as reserved words. In Python, there are 33 reserved words. And these are those reserved words: true, false, none, and, or, not, is, if, elif, else, while, for, break, continue, return. These are the conditional statements. Try, except, finally, rise. These we use in object-oriented programming for exception handling, for importing any class, for importing libraries. We import reserved word, lambda, delete with, non-local, global. All these are the reserved words. All the reserved words are small letters, that is lowercase letters. Only true, false, none. These three reserved words start with the capital letter. In true, capital T; false, capital F; none, capital N. These are the reserved words. We cannot use these reserved words while giving the name to a variable or an identifier. If we give the reserved words as a name, it won't accept that. Now we will see the data types in Python. Data type represents the type of data present inside a variable or memory. In Python, we are not required to specify the type explicitly. It means that it is not required for us to mention it while declaring a variable. If your a equals to 10, it will automatically takes that 10 as integer. We need not to give int a equals to 10. That is what we are saying. We are not required to specify the type explicitly. Based on the value provided, the type will be assigned automatically, as I have already told you. The types of data types in Python are built-in data types and user-defined data types. Under user-defined data types, array, class, module comes there. Now we will discuss about the built-in data types. These data types are provided by Python language itself. These are the following built-in data types. The first one is none type, numeric types, sequences, sets, mappings. Now we will see what's the none type. None data type represents an object that doesn't contain any value. If the object doesn't contain any value, it will show the none data. It will show none, just like null in C and Java language. Next, the type is numeric type. Int, float, complex. These data types come under numeric type. Int data type. The int data type represents the integer numbers. Any integer number without any decimal point or fraction part is considered as an integer, and it will automatically takes that value as an int type in Python. It is possible to store very large integer number, as there is no limit for the size of an int data type. It means that in Python language, we can have a very large integer number because there is no limit for the size of the int data type in Python language. And I will show the examples in the IDLE after seeing these three data types. And next, the data type is float. And the float data type represents the floating point numbers. A floating point number is a number that contains a decimal point, like 25.56, 10.4, 0.4, 0.5. If there is a number which has a decimal point, then it is considered as floating point. And the next data type is complex. A complex number is a number that is written in the form of a plus bj or a plus bj. Here a is considered as real part of the number, b is the imaginary part of the number, and j is square root of the value minus 1. A and b may contain an integer or a floating number. There is no strict rule like that. A should have A and B will be only integer. It's not like that. A and B can be an integer type number or a floating point number. Now let's see these numeric type data types in the IDLE. If I give A equals to 10 and enter, it will take A equals to 10. If we want to check the type of the data that we have entered, whether it is integer type or floating type or complex data type, there is a keyword type in Python to check the type of the variable. Type of A. It gives class of int. It is integer type variable. Now if we give A equals to some 5, 6, 8, 9 and type of A, Now it gives class of int, and if we give f equals to 10.678 and type of f, it gives class of float. And also if we give p equals to 10.0 and type of p, now it is also a class float. If p equals to 10, then type of p is class of int. If we give p equals to 10.0, there is a decimal point 0.0, so it is float data type. In p equals to 10, it is an integer data type. And also if g equals to 3.5 e5, the type of this variable g is float. Then what is this e represents? This e is the exponentiation power of 10. The value of that is 3.5 into 3.5 into 10 to the power 5. This is the value of 3.5 e5. E is the exponentiation power of 10. That is 3.5 into 10 to the power 5. If we assign a variable s equals to this, we'll get type errors. We'll get type error because this operand, this special symbol, caret symbol, is not supported by the floating type or integer type, so we will get a type error. So we will use the exponent e to represent this kind of number, that is raised to the power 10. We can also give t equals to 4.5 capital E6. This is also supported. We can give either capital E or small e to represent the exponentiation power of 10. If we check the type of t, it is float type. Now we'll see what the complex numbers. I will assign a variable name com equals to 3 plus 5j. It will take that type of com. It is class complex. The data type is complex data type. We can also give c equals to 3 plus 6 capital J. Capital J is also accepted here. Type of equals to complex. If j I will give q equals to 6 plus j8. Now this is not accepted because the format of giving complex numbers in Python language is a plus bj, not a plus jb. We have to give the format of complex numbers only in the format of a plus bj, not anything else. And also we should not I will show you the example. When I, this is also not accepted in Python. it will show the invalid syntax or syntax error, because the format of complex data type is a plus bj, not any other any alphabet. We should only give j, not I or something else. And the format should be, and also we can give the a and b value in the complex numbers with either integer type or floating type. Now we'll give the floating type number 6j. It will accept. If we print it, it will give the same number. Print, not print, we'll check the type of variable. It will give. This is all about the data type, numeric data type. Now we'll see the next data type, that is bool type. The bool data type represents boolean value. Boolean values are true or false. Python internally represents true as 1 and false as 0. The binary value or the internal value of true in Python language is 1, or and for false is 0. We can use this data type to represent Boolean values. The only allowed values for the bool type are true and false, and that too the first letter T should be capital, and F in the false F should be capital. The value of true is 1, the value of false is 0. If we give true plus true, then the value is 2. If we give true minus 4, then the value is 1. Now we'll see this in the IDLE. Now let's see one value, b equals to capital TRUE, true. Now we'll see the type of b. It is class bool. If you print the value b, then it is true. If you assign a equals to false, now I'm giving small f, then it shows name error. Name false is not defined. So we should give only capital F false. Type of A, it is bool type. If we print the value true plus 2, it is 2, because internally Python takes true as 1, so 1 plus 1 is 2. If it is false, capital F false plus, I will give minus false, value is 0, because 0 minus 0 is 0. If I give the value false minus true, then it is minus 1, because 0 minus 1 is minus 1. If a equals to 2 and b equals to 9, if we check some c equals to a greater than b, and if we print c, here we will use print statement to to display the output or to display the variable value in Python language. I will discuss these operators later in later session. A equals to 2, B equals to 9, and here we are checking whether A is greater than B. If A is greater than B, then it will print true. If A is not greater than B, it will print false. Now let's see what's the type of class bool. This is all about the bool data type. Now we will see the next data type, that is sequence type. In sequence data type, we have strings, list, tuples, and range. We'll see what is about string. String represents group of characters enclosed in a single or double quotes. Actually, if it is in other languages like C and Java, if we give S equals to capital H within double quotes or single quotes, it is represented as char data type. That is char because we are giving only one character in it. But whereas in Python, if it is one character or a group of characters, it is considered as a string. And these strings are enclosed in single or double quotes. These characters are enclosed in single quotes or double quotes. So we'll see the example of this. In the shell only, s equals to df r, with I have given within double quotes, and we'll see what's the type of s. This is str. Str represents the string data type. If we give d equals to single quote something else, something I have given inside, and if I take type of d, it is in a string class. If I give 1 2 3 within double quotes, a number within double quotes, if I check the type of that variable, it is also a string data type, because it is all, if we give a number within the double quotes, it is considered as a string. We can give anything within double, whatever we give within double quotes, it is considered as a string. We will discuss more about string in the later session. And the next data type is list. A list represents a group of elements. It can store different types of elements which can be modified. Basically, lists are mutable, and the lists are represented using square braces. Whatever we give under within the square braces is considered as a list. For example, a equals to 1, 2.4, high. These are the elements in the list. We can give group of elements, and these elements can be of various data types. Here one is integer type, this is floating type, and this is a string. All this combined together we can give within a list. This list can be accessed through indexing and through slicing. Now we will see few examples related to this list in the IDLE. I will give a list L equals to 1 comma 5 comma 6.66.7 comma some, and I will also give few strings in this and number integers. Hello, enter. If we check the type of L, it is class list. If we print this, the it will be in this format. This is a list. We can only give integers 1, 2, 1, 3, 5, 32, something. Some numbers, if we give, it is also considered. Type of P. This class of int. In a list, we can only give floating numbers 2.1, 3.4, 67.8. This is also a list. We can only give a string within a list A, B, C, and that's it. It's enough. Type of K. Again, it's also a list. We will discuss. We can have a great discussion or more discussion on list, and this list is discussed by Harshita in later sessions. You can learn more about the list there. This is enough to learn about the data type list here. In detail, you can learn later. And the next data type is tuple. A tuple contains a group of elements which can be different types. It is similar to list, but we cannot modify the elements in a tuple. In a list, we can modify the elements, but whereas in a tuple, we cannot modify that. And also, the tuple can have different types of elements. It is represented using parentheses, whereas lists are represented using square braces, but whereas tuples are represented within using parentheses. Now let's see the example. I will copy this. Here I have given D equals to open brace 10 minus 20 285.9 high H. If I enter, it's showing syntax error. I think I have copied this, so it is showing D equals to, I will give the same data 10 comma minus 20 comma 289.5 comma within the brace H, within the quotes H. It's taking, because as I have copied that, so it's showing some error. Therefore, D. It is class of tuple. We cannot modify the elements within a tuple. In a tuple can have similar data type, similar data like only integers. And type of F class tuple. If we give H equals to open brace 5.4 comma minus 4.897 comma minus 4.0, and type of H, again it is a class of tuple. If I give P equals to empty brace and type of A, again it is a class tuple. If I give empty braces, if I don't give any of the value within these braces, it is also considered as a tuple, as tuples are represented using brace parentheses. I haven't showed you using tuple. If we give empty square braces and if we check the type of L, it is a class of list. This is about tuples, and you will learn about the tuples in the later session by Harshita. And the next data type is range. This range represents a sequence of numbers. The numbers in the range are not modifiable. It means if we can give a range of numbers, represent a range of numbers using a keyword range. If we give 5 are equals to range of 5, then the sequence is from 0 to 4. 0, 1, 2, 3, 4. If we give 5 here, the numbers up to before before 5, or we will get that numbers in the output. If we give r equals to range of 10, 22, then the range, the output will be from 10 to 19, but it will step ahead by 2 steps, like 10, 12, 14, 16 and 18. I will show you in the IDLE. R equals to range of 5. If I print R, it is showing 0, 5. If I print R, it is showing that the range is from 0 to 5. And here I have to use a for loop to print this, for otherwise it will only show the range. For I in R, print I will print from 0 to 4. In the later session, we will discuss about these for loops, how to what is the syntax of for loop, how we can write a program using for loop. For just understanding range, you just remember this keyword range. If you want to give, if you want to use the data type range, you have to use a keyword range. Within the braces, you have to give the range, and also r equals to range of 10. I'm showing the same example which I have explained, which I have shown you before. And for I in range of, for I in R, no need to keep range because already we have given the range. For I in R, print I. If I print I, it's showing 10, 12, 14, 16 and 18. What now let's say the type of class range. The type of R is range. Now let's see the next data type, set type. A set is an unordered collection of elements, much like a set in mathematics. A set is an unordered collection. Where in list and tuple, if we give some elements within that, the order will be same. But if we give the elements in the set, the collection is not same. That is, the elements, if you have entered 1, 1, 2, 3, 1, 1, 2, 3, 4, 7, like that, the order may have changed from 3 to 1, 7, like that. The order will not be same. The order of elements is not maintained in the sets. as I have already told you. It means the elements may not appear in the same order as they are entered into the set. Its set does not accept duplicate elements. We cannot give two elements like 1, 1, 2, 2 or high, high in the set. It won't accept duplicate elements. Sets are represented using curly brackets. For example, d equals to 10, 20, high 30. If we give these elements into the set, the order may not be same in the output. We may get 20, 10, 30 high or high 10, 20, 30 in some other order, or we can get the same order also few times. Now we'll see the example. I will give S equals to we represent sets using curly braces. So open curly brace 3, 5, 1, 3, 6, close the curly brace, and we will print S. Now you can see that if we use a set, I have given the elements 3, 5, 1, 3, 6. 3 has been repeated 2 times. As sets does not allow duplicate elements, so 1, 3 has been removed, and you can see that the order we have the order of the elements have also changed here. We have given 3, 5, 1, 3, 6, but in the output we got 1, 3, 5, 6. So set is told as ordered collection. It is an ordered collection. And also we can give different data types in the set. I 7 9.0 hello. If we print s, it is again the order has been changed. The order we won't get the same order in the sets. Now let's see the type of S. The type of S is class set. And the next data type is mapping type. Mapping type, dict or dictionary. These represent mapping data type is also called as dict data type or dictionary data type. A map represents a group of elements in the form of key value pairs. That is nothing but the format of dictionary. As mapping type is also known as dict or dictionary. A dictionary represents a group of elements in the form of key value pairs. It is again represented within the curly braces, but in the exam I will give you an example. You can get it better. Here the data is the variable name. Data equal to open the curly brace. Here 1 is the key, and apple is the value of this key. In between you have to use the colon. This is the syntax of dictionary data type. Key is to value. The key we can give the key value as string or an integer, and value as string or an integer. Now I will show you with an example so that you can get it clear. I will give the same example. Data equals to open the curly brace 1 is to comma 2 is to banana curly brace enter data. It shows we are getting the output. If we check the type of data, it is class dict. If we want data of when we can retrieve this output, we can only get the value of key 1, that is data of 1, enter. Sorry, this top text is not callable. If we use print date of print data of 1, we will get apple. This is the format to get the data of 2, banana. You are getting it. We can also have the key as string. Fish is to 2, carrot is to 9. Enter. We can give the keys as strings and values as integers, and we can give both key and value as a string and both key and values as a integers. Whatever we want we can give as key and value. Now we will see about the input and output statements. Input of. Input of function can be used to read data from keyboard in the form of string format. The data whatever we enter into the keyboard is taken as string, and then we have to convert that string type to our required type by using the typecasting methods. Whatever the input we give within the input of function, it is considered as a string. But every time we don't require a string, because we require some other types of data types like integer type, float type, etc. At that time we have to use typecasting methods. Typecasting methods are nothing but we are converting one type of data to another type, like from string to integer or integer to string type or integer to float or float to int, like that. Here is an example how to write input of function. We can assign the input of function to a variable x or x, and x equals to input of, within the parentheses we have to, and within the quotes we have to enter the message whatever we want, enter value. Then when we execute this statement we will get in the output like in the compiler or the command prompt as enter value. At that time we have to enter some value. If we if we give 10 to this variable x, it is a string, not an integer. Even though we are passing 10, it is taken as string. If we typecast that by giving int of input of enter value, then that string is converted into the integer type, because we are assigning int before the input of function. Here we are performing typecasting. Now we will see this in the IDE. I will give some x equals to input of within the braces I'm giving passing the message enter value, enter. Now we are going to enter the value 4. If I type x and enter, the value is 4. You can see that in the previous examples we have seen that if we are passing a string in the output also we are getting the string within the single quotes. Now we have got this 4 value within the single quotes. It represents a string. Let's see what's the type of it. No need to believe me, you can believe by seeing this type of x. And now this is the class str. Str is string type, class string. What the input we have entered for is a type of string. This is an integer type, but it is showing string type. What if we give a float value to this? Let's see that. Again, I'm declaring a variable y equals to input of the value, and now I'm entering the value as 4.7. If I type y, then it is showing me 4.7 in the string format. If I get the type, it is string type. So what to do if we want to change this string format into the corresponding integer type or floating type? Just perform typecasting. Now I am doing typecasting int of x, that is 4. Now if I print x, get 4. Now it has been converted, the string format has been converted into the integer type. Now let's check what's the type of x. Type of x, it is class of string. Again it will show this message only because the value we have entered here is a string type. If we want to change that, right, then if we don't want to get this string type, rather than if we want to get the integer type, we have to give the input statement with typecasting at the beginning. Y equals to int of input of enter value, enter value for type of y. Now it is showing class of int because at when you are declaring the variable, at that time only we are giving the typecasting before the input statement. It is the reason why here we are getting the class type as integer. Here we are not getting the class type as integer, but in the output the type the variable what we will get is integer type. After when we convert this x into int of x. And also if we want now let's run a program. I have shown this in the shell script. We will write a program now. We will write a program to but that takes two inputs from the keyboard and performs sum on it and displays the sum to us. Now I am declaring two variables x and y. X equals to int of input of enter first number and closing the braces. Y equals to int of input of enter second number. And now I am printing this print sum comma I plus j, sorry, x plus y, x plus y. Before when we try to run this, it will ask us the source must be saved. Okay, now I am saving this file as test.py because every Python program has to be saved with .py extension. Save. I have saved it. Now I am getting enter first number. I will enter 6 and enter second number. I have entered 4 and the sum is 10. 6 plus 4 is 10. This is how we can write a simple program by taking two inputs. In the same way, we can take many multiple inputs from the keyboard if we want the user to give the input rather than the programmer. Now we will see the output statement. Already we have used the printf function, that is the output statement. It is used to display output. Not only output, but it will display the message also, what we are going to if we want to pop up with the user. Printf function can be used without an argument also. What is that means? Here I have given the example print hello world. Here we are just displaying it as hello world in the output screen, but we are not passing any arguments here. So this format is called as printf function without an argument, without any argument. Just it prints a new line character. If we want to pass number of variable number of arguments, we can we can perform like this. When you are assigning three variables with three values, a equals to 10, b equals to 20, c equals to 30. Otherwise, in other format, we can give like this: a comma b comma c equals to 10 comma 20 comma 30. Now the value 10 will be assigned within variable a, and for value 20 b is tagged, and for value 30 c is tagged. Now if we want to print the values of a, b, c, we can print like print the values are, and we have to separate when we want to display a value, then we have to separate it with comma. We have to pass the argument by separating a comma b comma c. This is the message we want to display, and after that we have to put a comma and we have to pass the argument whatever the variable we want to, and this is a comma b comma c, and then the output will be like the values of 10, 20, 30. We can also separate the messages also by comma if we want to give them separately. Print hello comma world, then the output will be like hello world. Now we will see in the program. I am printing print hi everyone. This is printf function uh, with no argument. We are not passing any argument here. This is just a printf function which is displaying the message we have written within the quotes. If we want to pass arguments, we have to assign a value to a variable like a equals to 10 or something else, and we have to print the value of a comma a. When you are passing an argument in the printf function, after the message, that is after double quotes, we have to give a comma, and then we have to keep the variable, we have to pass the variable name. And when we print this, I will get the output like the value of a is 10. What if I want to um, get a message after 10 also, like the value of a is 10, and then you have executed it successfully. I want to get that after 10 within the same line. Then what should I do? Then we can write this print statement as print of the value of a, close the brace, comma a, and then again you have to keep a comma, and you have to start the open double quotes, and then execute it. Close the double quotes and the parenthesis, and then enter. And now we are getting like the value of a is 10 and executed. After passing the arguments also, we can display our message after that. This is the format. But when you are if you want to display the message after the argument, again we have to separate that with a comma, then it will. If we don't separate this with a comma, then we will get an error. We will also see that. Print value comma a, execute, enter. Now it is showing invalid syntax because I have not given comma here. So it is showing invalid syntax. This is how we can write the printf functions in different fashion. And again there is an printf function with end attribute. What does this mean? You can just print hello. Okay, sorry, I have not given the closing brace, and then print world. You cannot see the difference. I will show you in the file program. I'm going to file, new file, for the window has been opened. Now I'm going to print hello, close the brace, and then print world, and then I'm going to print good morning. Now I'm going to run this program. Before that I have to save this. I'm going to save this on the desktop itself. I'm giving this name as test1 because already we have given test. I'm saving this with .vue extension. It is must. Now it is executed. Hello world, good morning. This type of printf method or statement is called as printf with end attribute. And also we can print the uh, object statements, like if we want the objects, if we give a string, sorry, list L equals to 10, 20, 30, 40. A list can also be print passing the message list, comma, L. And I will print a tuple also. I will define a tuple as T. 2.43, comma, 8, comma, I print tuple, comma, T. Run module. I have to save this. Okay. I am getting, I am able to print the list here, and I'm going to print the tuple here. Okay, we can, by using the printf statement, we can print a pop-up message or the message whatever we want. We can print an argument. I can print various number of variables by passing the arguments, and we can print the data types, list, tuples, and also we can give the arguments within a line. If I give a comma b comma c equals to 10 comma 20 comma, I'll have to separate this with comma 10 comma 20 comma 30, and values are comma a comma b comma c. This is passing variable number of arguments to the print statement. Now I'm going to run this. I'm going to save this again. Now we am getting the values are 10, 20, 30. Here the value of 10 is A is tagged to value 10, B is tagged to value 20, C is tagged to the value 30 in the order. If I give 20 here rather than 10, if I give some 80, then A is tagged to 80. This is the format that how to print statements using printf function, which is an output statement in Python. Now we will see what are the operators in Python. Now what is an operator? Operator is a symbol that performs certain operations. It is used to perform some operations. What are those operations? It is used to perform certain operations. Python provides the following set of operators. Here we have seen what is operator. Now there are few set of operators in Python. We will see those one by one. The first one is arithmetic operator, relational operator, logical operators, bitwise operators, assignment operators, and special operators. We will see what this assignment operator is and all these operators individually. First, we will see what are arithmetic operators. Here, plus the symbol plus, minus, asterisk, slash, percentage symbol modulo, double slash, and double asterisk. These all are called arithmetic operators. Plus is used to perform addition of, minus is used to subtraction, asterisk is used to perform multiplication, slash is used to perform division, and this is called as division operator. And percentage symbol is used to perform modulo modular division. And this is called as modulo operator. Basically we call this as percentage symbol in the local language, but as per the programming language this symbol is known as modulo operator. This double slash is called float division operator. This is used to perform float divisions, and double asterisk is used to perform, and double asterisk is an exponent operator to find the power of some number. Now we'll see an example of this. I'm closing this windows. I'm taking a file, new file. I will take two values, a equals to 10, b equals to 2, and I will print. Now I will print. I will give the message sum, comma, a plus b. Here we are performing some addition, and then when I'm going to perform subtraction, difference comma a minus b, and then I'm going to perform multiplication, product comma a asterisk b, and here I'm performing division. When I perform division, I will get the remainder. Here A is dividend and B is divisor, and the output of A by B, I will get the quotient. But whereas when I perform modular division, I will give this modular division as the pop-up message, comma A modular operator B. Here the output I will get as quotient of A by B. And again I will perform floor division. I will give this as floor division. A double slash B. Again I will perform print exponentiation power A double asterisk B. Now I'm going to save this again on the desktop as test2.py. I'm saving this. Now it is run. After performing the operation sum, I'm getting sum as 12. Here 8. Here 20. The product is 20. And the division is 5.0. Here I'm getting the quotient in the division, and in modular division I'm getting the remainder. Sorry. In division I will get the quotient. In modular division I will get the remainder. In floor division I will get the same thing but in the integer format. If I pass the argument in any argument in the float type, then the output I will get in float data type. If both the arguments are integer data type, then the output in float division is integer data type, integer type. Whereas in division it will give float data type. in normal division. In floor division, it will change accordingly. And the exponentiation power is 100. This is about arithmetic operators. Now, the next operator we are going to see is relational operators. These are the operators which are called as relational operators. This double equals to is used to check whether the two variables or the two strings are equal or not. This is and the name of this is equality operator. This symbol exclamatory mark equals to is used to check whether two variables are not equal. If x not equals to y, and greater than symbol to check whether in which variable is greater than the other, and less than symbol to know which variable is smaller than that, greater than or equals to, and less than or equals to. These are the relational operators. And again we'll see this in the program. Here I am giving a equals to 10 and b equals to 10. If I print directly, I'm going to print this. Print a greater than b is comma a greater than b. Here I am giving the pop-up message as a greater than b is, so that we can understand what will be the output. And then enter. Print a less than b is comma a less than b. The output we will get whether it is true or false. Print a greater than or equals to b is equals to b. And print a double equals to b is comma a double equals to b. And print not equals to b is comma a not equals to b. So we'll see up to this. I'm going to run the program. Again, I have to save this. I'm saving this program on the desktop and giving the name of the file as test3.py, and I'm saving this. Now it is executed. I have given a value as 10, b value as 10. If a greater than b, it only checks whether a is greater than b. 10 is greater than 10, it is not true, so it is false. A less than b, 10 less than 10, it is false, so it is displaying the output as false. A greater than or equals to b, a greater than or equals to b, that is if a is greater than or equals to b, it is true because a is 10, b is 10, that a is equals to b, so it is true. A double equals to b, this will also true because 10 equals to 10. A not equals to b, this is false because a is equals to b, so it is displaying the message false. This is about the relational operators. Now we will see what are the logical operators. Logical operators are used to combine conditional statements. What are these are used to combine conditional statements. What are the logical operators are 10, sorry, and if both arguments are true, then only result is true. If both arguments are false, if at least one argument is true, then the result is true when we are using OR operator or logical operator. If when the not is an third logical operator, it complements the result. If both arguments are true, then only the result is true when we use AND operator. When we use OR operator, if at least one argument is true, then the result is true. If and not operator complements the result. If you are giving 1, then it will, if you are giving true, then it complements it as false. Now we will see few examples regarding this. I will give A equals to 10, B equals to 5. Print A greater than A less than 10 and A and B than 3. And here, see, I am giving the statement as A less than 10. Now, what will be the output for A less than 10? This is false. And B greater than 10. Is B greater than 10? Yes, it is greater than 3. So, it will be true. The output of B greater than 3 is true. This is the condition statement. And A less than 10. This is false. And now we will get the output as false because one is true and the other is false. This is how we are going to use the logical operators. If I give print A less than 10 or B greater than 3, now I will get the output as true because I am using OR operator. When I am using OR operator, I will whether if one of these two statements is true, then the output will be true. This is about the logical operators. And now we will see the operator, that is bitwise operators. These are the bitwise operators. All these symbols are the bitwise operators. This is the ampersand symbol. If both bits are 1, then only result is 1. Otherwise result is 0. This symbol is used as OR and this is for AND. If at least one bit is 1, then result is 1, otherwise result is 0. This is the pipeline symbol we are using as OR, as this is a bitwise operator. If bits are different, then only result is 1, otherwise result is 0 when you are using this caret symbol. If bits are different, then only result is 1, otherwise 0. If it is 1 and if one bit is 1 and the second bit is 0, then the result is 1, otherwise the result is 0. For this tilde symbol, this is the complement operator, that is if 1 means 0 and 0 means 1, it complements the bits. If we are passing 1, then it complements it and it gives us the result as 0. These two less than symbols are called as bitwise left shift operator, and greater than symbols is called as bitwise right shift operator. Now we will see the examples. If I am going to print 4 ampersand 5, I will get the output as 4 because it is a valid one. This is valid, so we are getting 4 here. If I print true and true, this is also a valid statement, I will get true. If I print 4 pipeline 5, now the output is 5. If I print 4 caret symbol 5, the output is 1. This is all about the bitwise operators. Now we will see what are the assignment operators. We can use assignment operators to assign value to the variable. Usually we use x equals to 10. This is the normal assignment operator, and in Python gives us many compound assignment operators. What are these compound assignment operators? If we want to assign a value to x as x plus 10, already we have given x equals to 10, and we want to increment that value x by giving x plus 10, we can write this in a simple manner like x plus equals to 10, which means x equals to x plus 10. The list, Python gives supports many compound assignment operators. Here is the list. We can perform addition, multiplication, division, subtraction, floor division using these assignment operators. Here is the rest of the list. We can perform all these operations, all these compound assignment operations on the variables. Now we will see the examples. If I'm assigning x equals to 10, I will take the same example. X equals to x plus 10. If I print x, what will I get? 20. Rather than giving x equals to x plus 10, I can give x plus equals to 10. If I give this, now the output is 30 because already the value of x is incremented to 20. Now 20 plus 10 equals to 30. It is 30. We can also perform subtraction on this. X minus equals to 20. 30 minus 20 is 10. We'll get that. We can also perform multiplication. X into equals to 2. 10 into 2, 20. We will get the output as 20 here. And if we can also perform division, compound division here. X by equals to 2. 20 by 2. What will be the output? 10.0, as it is normal division. If it is floor division, we will get it as 5 because the value of x is 10. 10.0. 10.0 divided by floor division by 2. So the question will be 5.0. If I perform modular division, x modulo equals to 2, then the output is 1 because 5 by 2, 2 is divided, 2 2s are 4, and the remainder will be 1. When we perform modular division, we will get the remainder as an output. So this is all about the assignment operators present in Python. Now we will see the special operators. What is this special operator? There are two different types of special operators in Python. The first one is identity operator, and the second one is membership operator. What are the identity operators? We can use identity operators for address comparison. If we want to compare the address of two variables, we can use this identity operators is not. We will see in the program. I will take a new file and I will give the value a equals to 10 and value b equals to 10 and print is b. Now we are checking here whether a is b. If it is true, then I will say this. Sorry, I have to say this. I will run module, save OK, and I'm again now saving this program on the desktop by the file of the name test4.py and save. Now I will get the output as true because I have given the value of a equals to 10 and b equals to 10. When I assign value 10 to b and value 10 to a, the memory is assigned to the value 10, not to the variables a and b. Now a is tagging to 10 and b is tagging to 10. What is the address of 10? It is same for both the variables. So a is b is the output of a is b is true. If I modify this, b equals to 19. Now I will get as false because the address is not same. This is about the identity operators. I will show you the example for is not. A equals to a equals to 10, b equals to 20. A is not. It is true because the address of A is not equals to the address of B because you are passing two different values to A and B. Now we will see what are the membership operators. We use membership operators to check whether the given object present in the given collection. If we give a collection, if we want to check whether that element is present in that collection or not, we are using this membership operators. In and not in are the membership operators. In returns true if given object is present in the sequence. Not in returns true if given object is not present in the specified collection. I will give a list here 1, 2, 3, 4. Now I am checking 1 in L. It is true. 7 not in L. Now again it will give true because 7 is not present in the collection. If I give 4 not in L, it is false because 4 is already there in this collection, so it is showing false. If I print 4 in L, it will give true. So these statements have been satisfied when we execute there. So this is all about the special operators, identity operators, and membership operators. So this is the end of our today's session. Thank you everyone.